Let's solve the find bottom left tree value on LeetCode. Given the root of a binary tree, return the leftmost value in the last row of the tree. For example, here we'd return 1, and in this example we'd return 7. The way we're going to solve this is through level order traversal. So I'm going to retrieve in a list of list integers the elements on each level. So for example, in example 1, we'd have a list of list integers that looks like this, and in example 2 we'd have a list of list integers that looks like this. So as you can see, in level order traversal, we store the elements on each level from left to right. So well, the root node obviously is going to be alone, there's no other element, but in the second level we have 2 and 3. The 2 comes before the 3 because we start from left to right, and then similarly for the next level, 4 comes before 5 and 6, as you can see. And then finally, on the last level, it's just 7. So actually, before going any further, I realized something, which is the fact that level order traversal would return the first element in our last list. But what if our last, or our tree looked like this? Then the elements that we store would look like this. So with a list of list integers that look like this, and we are supposed to, or we're meant to return the leftmost value, you'd think that the correct answer is 2, which goes against what our level order traversal does. Because sure, it works for example 2, but in level order traversal, or what we're going to do in our code, is we're going to return the first element of our last list, which in this case is 4. If you look at the tree, 4 doesn't look like the leftmost value. You'd think it's 2, which is kind of confusing. So I went ahead and I looked at the discussion and some LLMs, and they said that problem statement simplified, basically, we need to return the first node in the last level. And if I go back to our tree, I'm not going to take credit for ChatGPT's answer, but his justification for an example like this is the following. So on level 0, we'd have 1. On level 1, we'd have 2 and 3. And on level 2, we'd have 4. And this is the last row, the deepest row. The only node on the last row is 4, so the bottom left is 4. It's both the leftmost and rightmost there because it's alone. And the discussion also mentions an example like this. So in this example, what would be the leftmost value? Since 1 is the only value, then obviously the answer is 1. So let's begin coding now. I will link a video to my level order traversal, or how to perform it, or how to code it. But if you don't want to watch that, that's completely fine. I'll try my best to explain as we go along in the code. So let's go ahead and do that now. So like I've been saying, we need to store the elements in each level in a list, and then store that list in a huge list. So let's go ahead and do that now. List of list integer. We can call it res for result is equal to new array list. And then what we're going to do is we're going to create a queue that takes tree node, and we can just call it queue equals new linked list. And then we're going to add to our queue our root value. So what we're going to do is we're going to create a list of list integers result to store the elements in each level into a list, and then just put all the lists together. And then we're going to create a queue. We're going to use a queue because we want to utilize the fact that in queues, elements are first in, first out. And we're going to go from left to right, and so we'll see what that looks like in a moment. And then we're going to add to our queue root. So let's keep going with our code. Now we're going to say while queue is not empty. And you might be thinking, well, queue only has one value, which is the root. but as we progress through the tree, we're going to be adding to our queue the values or the nodes to the left of our root and to the right of our root, as long as they're not null. Not not the nodes to the left and right to our root only, but to the node that we're on, and it'll make more sense as we go along. So let's keep going. Then what we're going to do is we're going to create an int level size, which is equal to q dot size, and then we're going to create a list of integer called current level, and this is going to initially be empty, so new array list. Let's go through these very quickly. So int level size equals q dot size. Level size is going to be equal to the number of elements on each level, because once we reach a certain block of code, we want to go through only the elements on the level that we're on, and so q dot size permits that basically. And then list integer current level. Like I said, we're creating a list of list integers called the result. So this is the list of integers that we're storing in list to, or the list of list integers that we're storing in list result. And we're going to be filling it up. So now we're going to iterate through the elements on each level. So for int I equals to 0, as long as I is less than level size I plus plus. Then we're going to store in a tree node called node the node within the first node within our queue, and then we're gonna add to our current level dot add the integer value of our node, so node dot val, and then we're going to check if node dot left is not equal to null. Then we want to add that to our queue, and similarly, if node dot right is not equal to null, and q dot add node dot right. Finally, here we just need to add to our list of list integers called result the list of elements on the level which we're on, which is current level. Okay, so before we actually do the final return statement, I want to go through our code just to make sure the point is across. Although I do explain it better in my level order traversal video, so if this isn't clear, go ahead and watch that. So what we're going to do is we're going to store the elements on each level into a list, and then with all these lists of elements on each level, we're just going to put them into one huge list. Then we're going to create a queue called queue that stores tree nodes, and we're going to utilize the fact that queues are first in, first out. So if we're on the second level here, 1 and 3, in our queue we're going to add 1 and then we're going to add 3. We want to make sure we process the 1 and we add it to the list before we add 3, because we're going from left to right. So first and foremost, we add to our queue root the first thing we're going to process, the first element on the first level. And then we're going to say while queue is not empty. Remember, because we have these two lines of code that are going to keep adding nodes into our queue until both of them are null, or because then our queue would be empty. But let's just go through it and see what happens. So while queue is not empty, we're going to create an int called level size, which is equal to q dot size, that will be overwritten every time we iterate through our while loop. Level size is going to be equal to q dot size because we want to process only the elements on each level. And well, if our level had 2 elements and q and level size we set it to equal to 4, then we're going to iterate through elements which are not there. So it's going to be equal to q dot size. And then we're going to create a list of integers which we're going to store in our list of list integers up here. We call it current level, and initially it's empty. We're going to be filling it up. Also, this is going to be overwritten after each while loop iteration. So now we're going to loop through our elements on each level. we're going to create a tree node called node, which is equal to q.poll. Q.poll will remove the first element we added to our queue. So for example, if our queue contained 4, 5, 6, then tree node equals q.poll will retrieve the 4 only. And then we're going to add just the value of our node to our current level list, which stores integers. And then if node.left is not equal to null, we're going to add to our queue node.left, and if node.right is not equal to null, we're going to add queue.add. Now this is where level size come in handy, because queue.size has already been set in this iteration of the while loop. So although we're adding elements to our queue.add, they won't be processed because queue.size is definitely less than what it would be after this code. So we're not going to process these elements. That's why level size equals queue.size comes in handy. And then, yeah, so we're going to add current level to our current level the value of the node which we just pulled from our queue. And then we're going to add to our queues the values on the left and right if they're not null. And then we're going to go back to this for loop and keep iterating until I is equal to level size. And therefore we're going to have a current level filled with the elements on each level, and so we can add that list into our result list. So finally, all we need to do is we need to return the first element in the last list of our res list. So let's do that now. Return res.get the last list, which would be res.size -1. Once we have the last list, we just want to get the first element. So that's pretty much it. Let's submit and see if it works. There we go. So that was the find bottom left tree value problem on LeetCode. I know, as earlier discussed, it's a bit confusing in the example that we saw, but seeing that our code worked, that's all we have to do. So I hope you found that video helpful, and thanks for watching.